Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
In this video, I will explain how to calculate chlorophyll and B. Understanding these pigment levels is crucial for evaluating plant physiological status and environmental stress responses. We'll walk through the steps, from sample preparation to applying the specific equations. This method provides a reliable way to quantify these vital compounds in your samples, giving you clear insights into photosynthetic capacity. First, you'll need to prepare your plant sample. Carefully grind a known weight of fresh plant tissue in a specific volume of 80% acetone. This solvent effectively extracts the chlorophyll pigments. After grinding, centrifuge the mixture to separate the solid plant material from the liquid extract. Then, carefully collect the clear supernatant, which contains your dissolved chlorophyll, for the next step. Next, use a spectrophotometer to measure the absorbance of your chlorophyll extract. You'll need to record the absorbance at two specific wavelengths: 663 nanometers, which is optimal for chlorophyll A, and 646 nanometers, which is optimal for chlorophyll B. Always use 80% acetone as your blank to calibrate the spectrophotometer before taking your sample readings. This ensures accurate and reliable absorbance values. Finally, apply the specific equations to calculate the concentrations of chlorophyll and B. For chlorophyll A, the concentration in micrograms per milliliter is found by multiplying 21 by the absorbance at 663 nanometers, then subtracting 81 times the absorbance at 646 nanometers. For chlorophyll B, the concentration is 13 times the absorbance at 646 nanometers, minus 503 times the absorbance at 663 nanometers. Remember to check the description for a link to the Owala water bottle and other great deals.
Thanks for watching. Consider subscribing if I helped unscramble your problems.